These types of simultaneous equations, we call them linear. Why do we call them that? Yeah.
Is it linear?
What is linear? Well, what's the difference between these two equations? Okay. Now, if you think back to when we're looking at coordinate geometry and like graphs and things like that, right? Linear is a term we use for like straight lines, right? So like a line, it's a straight line, linear. If I'm looking at nonlinear things, examples that we saw of that were like parabolas or cubics or exponentials and different curves like that. When we're solving nonlinear equations, we do have to be careful because remember, with quadratics, what kind of solutions do you expect a lot of the time? You expect kind of like multiple solutions, right? Sometimes you have positive or negative cases. So you have to be very careful when we're doing these. You should keep them in the back of your mind. You can still use the same kind of methods that we use, substitution and elimination, but you should expect, okay, maybe there might be some more solutions that I'm actually looking for here, right? If I look at something like this, just off the bat, what kind of method do you think I'd want to use here? Yeah, because I've got y equals to this, y equals to this. I can go ahead and use my substitution method, right? So again, I'll still label my equations. I'll let 1 equal to 2. I can do that. We'll say x squared is equal to 2x minus 1. And we've seen quadratic equations enough times to realize, hang on, I don't really want something that looks like this. I want everything to one side so I can actually solve for it. Because I'm still trying to solve for x at the end of the day, right? So I'll rearrange both sides. Now, again, we've learned a few different methods to solve a quadratic like this. We can factorize, we can complete the square, we can even use quadratic formula. But Harry, what's this guy going to factorize to? Two things that multiply to 1, add to negative 2. Minus 1, minus 1. Or x equals to. So x equals to 1, which is 1, or x equals to 1 is fine. Right? Okay, there's one of my answers. And that's one of my answers. I can find another one. If I sub x equals to 1 into, I think 1 would look a lot easier, right? Because there's just one variable there. Y equals to 1 squared, and that's just going to simplify to 1. And so there's my two answers. X equals to 1 and y equals to 1. Not too bad, right? In this case, we didn't have two answers, but let me show you one where that might not be the case. When we are looking at this one here initially, okay, there are only linear terms in the two equations. But when I'm talking about nonlinear simultaneous equations, it's not just that it has a quadratic in the original, but sometimes we might have to do some rearrangement, and then we might end up with a quadratic, right? Look at this one here. What did you start off by doing? Okay, so when we're looking at this particular one, I actually can't do elimination here. And the reason why is if I try to add these together, it's not really going to work because these two are multiplied together. Okay, so I'm immediately thinking substitution. Either one would work for substitution, but even within substitution, we can find ways that are easier than others, right? If I try to rearrange this one and get one of them as a subject, what would I end up with? I would end up with a fraction, right? And I don't really like those. I can work with them, but it's far easier to just look at this one and say what you did and say, let's add y to both sides. So this is equation 1, equation 2. So I'm going to make a new one. I'll say x is equal to 2 plus y. We can call that 3, right? I take this equation and I'll sub x into equation 2, right? That's the first thing I want to do. And then so I can take my x that I've found and I can replace it into that second equation. So I'll end up with 2 plus y outside of y equals to 15. And now you can hopefully see where this quadratic is going to come from, because if I expand this out, I'll get 2y plus y squared. What am I going to do next, Eva, here? Yeah, like with most quadratics, we want everything on one side. Yeah, like you said. So I'll rearrange this slightly. Now I've got my trinomial, and I want to factorize this. Sam, two things that multiply to negative 15 add to positive 2. Two numbers there. So again, think about factors of 15, right? You've got 1 and 15, 3, 5. Yep, let's check. Y plus 5, yep, and y minus 3. Cool. And so those are your answers, right? Y equals to negative 5 or positive 3. Now, here's where we have to be very careful. Because that's okay. We expected 2 answers when I was using my quadratic equations, right? And I can work with that. I can even sub that back in. I can say, all right, I've got 2 answers here. Let's put them back into the original equation. I suppose this one's not too bad, actually. So I'll sub y equals to negative 5 into 2. So I have negative 5x equals to 15. And so x is equal to 3. Negative 3, sorry. Or what's the other thing I have? I can sub y equals to 3 into 2. And I'll end up with something slightly different. I'll have 3x is equal to 15, or x is equal to 5. So those are my answers there. Are you happy with that? Yeah?
No.
Yeah? No, why not, Matt? I'm actually not happy.
Oh, God.
And I'll tell you why.
Oh, yeah, that's not
Because this is not clear. Like, I found some correct solutions, but it's not really clear what are they, right? You could just say all of these are right, but it's not actually true. Because, for example,
You can't just put whichever one you got.
right, if I just said, yeah, okay, if these are all correct, oh yeah, y equals to 3 and x equals to minus 3, if you try and put that back into there, you're not going to get 15, okay? So now, the careful thing you have to do when we have nonlinear simultaneous is you actually have to tell me which answers go with which one. And you know, because you've told me when y equals to negative 5, x is equal to negative 3. That's the only situation those work. They have to be together. So just as a kind of closing sentence, I've kind of run out of room, but I'll write it on the side here. So I would write it at like this. I'd say y equals to negative 5 and x equals to negative 3. Or, because we use the word or when we're talking about separate solutions or separate situations, what's the other case I have? I can have y equals to 3 and x equals to 5, okay? So just make it really clear what your answers actually are, because strictly speaking, this is not quite correct. You haven't really told me what are the pairs of answers that go with this. We're looking for an x and y, but more importantly, I'm looking for the correct x and y which go together. So you can see how that's really important that we write it out like that. Like, it can seem kind of pedantic, but it does actually change the answer to that one, right? Did anyone have a go at this one?
Yeah.
Yes, what did you try? Yeah. Add, okay. So, again, it looks a little bit scary with the square. We've got x squared plus y squared, x squared minus y squared. I was almost thinking difference of 2 squares, right? If you tried that out, it actually doesn't work. But, like I said, we can always use our normal simultaneous equation methods of, elimination or substitution. And so if I have the same signs, I want to subtract these equations, right? That was my SSS kind of method. So let's subtract these out. Actually, I think both work. I think you can actually do adding or subtracting. Can you guys see how both of them would work?
Oh,
Yeah, because if you add them, these would go away. And if you subtract them, these ones would go away. So which one did you do, Laura? I added them. I think I'm going to add, actually. So because if you add them, you'd get 2x squared, and these two will go away. Yeah, and equals to 98. And that's easy enough to solve. X squared equals to 49, cool. Ah, great, good observation. Right, again, in the back of my mind, I've got a quadratic, I'm thinking, okay, don't forget plus or minus, Because it's so easy to leave that off and just say x is equal to 7. You're right, but it's not the full picture, right? So now you want to say, I've got positive and negative cases. And again, I can substitute them both back into, either equation will work. Let's go this one, because it's already positive y squared there, right? So let x equal to 7. Or sub, keep writing let. Sub x equals 7 into 1. And so we get 49 plus y squared is equal to 53. And then y squared is equal to, what's that, 4? And again, plus or minus, so what do I need to consider? Oh, sorry, I just said it. Squared, so I need to consider plus or minus. So plus or minus 2, right?
But with this one, it doesn't matter if you have -7 to
Ah.
7 minus.
Okay, let me just finish it off and then I'll talk about that, right? So that was just for x equals to 7, okay? I was actually doing one of those. Let's do the other variable too. The sub x equals to -7 into 2 and, sorry, into 1. Let's go with 1, it's very easier. What happens when I put -7 into here? It's still the same because negative squared is just going to be positive. So 49 plus y squared equals to 53. And I get the same equation, right? So then my question is, what's the answer? Can I just leave it like that? Didn't I say I wasn't content with just leaving it with something like this, right?
But it depends, like, does it matter in this case?
Doesn't matter.
What can you say, unless you want to write it up, that like 4 times?
It doesn't matter because they're squares.
It doesn't matter because they're squares. And you guys are right. It doesn't matter because they're squares. Now, if I was mean, and I am mean, I think you're exactly right. There are actually 4 sets of solutions for this one.
Would
Right?
you make us write out all? Take it easy.
Because look, if I put in x equals to 7, I get 2 answers for y. And if I put in x equals to -7, I also have 2 answers for y. So if you want full marks for this question, and if I'm saying, look, what is the answer here? I actually have 4 answers. If x equals to 7, y can equal to 2. But if x equals to 7, y can also equal to -2. And the same for negative here, right? If it's -7, I can get a +2. And if it's a -7, I can also get a -2. The important thing to realize, though, is that all of these are separate. So literally 4 sets of solutions here.
If you just left x equals +/- and y equals
Yeah.
+,
It would depend on how mean they were, right? Like, I think it's hard to say. And I want to give you every possible chance of getting the marks you deserve. Because you've done all the hard work here. If you just wrote 4 more lines, it's not too hard, right? I think, like, the whole goal of this is to say, okay, what's my answer here? I've done all the hard work. Here are the actual answers.